setting up links. Facebook done, just do Twitter. Stars once a few people have joined. Discord. Good. And Rusty. Yeah, I'm okay. Good. Very crusty. Who have we got here? 7 watching and only 2 commenting. So who have we got? We're all being stealthy. Just make sure that, yep, still in the right folder. Let's remember where we were up to. Right, so we've got things moving around and no collisions, no shooting. Load game 2.odn. And hey Nigel. Right, I had a request to comment over the layer 2 stuff. So let's look into that. Right. Anyone not know? Anyone not want comments on the layer 2 stuff, or does somebody want me to comment through this? So I describe everything that's going on in it. And then we've got some of the old stuff there, but that's from the old ULA stuff. Hang on, let me just check. Can you hear me? The audio's here, and if I unmute this, you'll hear an echo. Can you hear me? Yeah. So anyone else not hear me? Or is it just Nigel? Testing, 1, 2, 3. Yeah, the audio levels here seem okay. Like I say, is anyone else that's watching got any issues with sound? It sounds fine with Stuart. Okay, so it must be your side, Nigel. I'm glad he can't hear me. So you're all okay with me commenting through this? Do you want me to do the CLS stuff as well, or just the layer 2? Because this CLS is ULA. It's a pain having a slow stream delay. Yeah, your side, no worries. Just layer 2, okay. Thought so, because the ULA is pretty, well, I say pretty straightforward. It's probably the worst of the lot. Right. E equals, I think, E equals collect to fill bank with. Oh. I should bring the tabs back in. 8 equals 9, which is the first bank, first 16K bank for layer 2. Call clear bank. 8 equals 10, which is the second, or the middle, 16K bank for layer 2, 256 by 192. Because if it was the 320 by 256, then 11 is the middle one. Right, so it's top, middle, and bottom. So yeah, first 16k bank, middle and last. I won't. Oh, well, do so. Clear bank. Jump. Clear bank. This is jump to save doing call, then ret. And basically the jump will, when it returns, it will return to whatever called clear L2 or clear L2E, rather than having to call clear bank and then return back to the line after jump clear bank, or after call clear bank if we change it to call, which would then be a ret. So it saves just doing an extra ret and saves a byte as well. Right, draw L2 room. Right, D equals A, which is room number. Multiply room number by 12 times 16. Right, because the blocks are 16 by 16 pixels, so 12 is the Y and 16 is the X. Because we've got 16 blocks across and 16 by 16 blocks down. So that's why we've got load with 12 times 16, because 12 blocks times 16 pixels for each block is 192 deep, and 16 across by 16 pixels is 256 pixels, so it fills the screen. Right, point HL to room data, add room offset to HL. So HL now points to first block. Right. So we all got that so far. Hey, Matt. We're just going through commenting on the layer 2 stuff, which is in the screen handler.odn file. D equals 0, top left of screen. Pixels. Alright, yeah. B equals 16, as we want 16 tiles, or blocks, sorry, across. Get first block number. From gel. which is room data. Plus the offset, right? Point HL to next block. Ready for next time in this loop. Call draw L2 block. I think I don't need to comment more than that because it will draw a layer 2 block. Basically, we need to add 16 pixels to position of next block. So we load A, E, put a colon here, add A, 16, and put it back in E. Load B, A. We do this as you can't push B, can't add to C, B, D, D, E, H, L. And IX and IY, IXL and IXH and IYL and IYH, but I won't go into that yet. So go through A. Right, now loop back 16 times as we set B to 16 earlier. Now need to add 16 pixels to next line down. Right, the reason we don't need to reset E or subtract 256 is because it's only an 8-bit number. So when you add 16 to, so it starts off at 0 up here, and when you add 16 to it 16 times, it comes to 256. But as 256 is a 16-bit number and not an 8-bit number, it only stores the low bit, the low byte, so it's 0. So it ends up going back to 0 on the last one of the loop. Down. So now we need to add 16 pixels to next line down, which is the D register for Y position in draw L2 block, and store it in D. Store it back in D. Right, have we reached bottom of screen yet? Question mark. If not, jump back to DL2 or CLP. And then return. Right, does the first 16k bank exist in ROM? The first 16k bank, well, the first 16k bank is initially set to ROM, which if you want to set, like, say you change the what's in what RAM is in bank 0, then it is if you want to change it back to ROM, then you set it to -1 when you're doing the MMU registers. Is that what you mean? No, when basically the ROM is usually paged in at 0. On the original spec, it was just always in at 0. And so, yeah, although it's ROM, when you're using the next, you can page that out and put RAM in there instead, and do any of the however many banks we've got. So when you're usually paging in the RAM, it's just RAM, it's not ROM, unless you set the value to -1. So if you ever see an MMU reg getting set with -1, all you're doing is putting the ROM in there, for the first two anyway. I'm not sure if you can, I've never tried that actually, setting ROM values in higher addresses. I wonder what would happen there. I've never tried it. Darren Bowles, glad the audio is fine for you. Then screening the next three. After that's up to the coder. No, Matt. Right, because in the next you've got either 768k to play with, or you've got 1792k to play with, and you are well, in the 2 meg versions you've got 1792k to play with, and you can split that down into 16k banks or 8k banks, and what you put where is totally up to you. And with the 48k, you only add obviously the set 16k of ROM and 3 banks of 16k, because the Z80 can only address 64k, so it can only address like 4 16k banks at a time, or 8 8k banks at a time. And the joy of the MMU registers is you can set them to whatever value you want, which will bring banks, any bank from anywhere in. When you're using the banks 0 to 7, that's the original 128k memory. So it's weird the way the 128k memory is set out, because you start off with the I'll use the 4 fingers. You start off with the ROM in the lower 16k. Then you've got bank 5, which is a 16k bank 5 in 4000 to 7FFF. And then 8000 to BFFF, you've got bank 2, 16k bank 2. And then in C1000 to FFFF, you've got bank 0. I don't know why they chose bank 5, 2 and 0. I don't know. But it just makes it a pain in the arse, I guess, when you're working things out, because your code is in bank 5, 2 and 0 when you start. Although ours is probably set to something different because we're using Odin. But normally when you run a next file or a SNA or an SNX, then the banks are 5, 2, and 0 for the from 16384 4000 hex to FFFF. It's bank 5, bank 2, bank 0. Cheers for that, Ped. With the -1 in upper MMUs, do nothing. They're on the map there. So yeah, I don't know what RAM will be mapped there, if any, or whether it'll just be floating. I don't know. I haven't checked it, and I guess if someone wants to check it and let me know, then that would be good. Maybe I could ask it. Alan, he'll know. I think what I'm trying to get your head around is if we have 48k of memory for the whole program, but we have 3 banks for 16k video. Yeah, they're all separate. It's a separate 48k, Nigel. Yeah, no worries. Don't say sorry. It's very confusing, especially with the fact that you got bank 5, bank 2, and bank 0 for your 48k. So yeah, you've got 8. Well, we'll talk in 16k blocks for the moment. You've got 4 16k blocks that you can have in memory at once. 1 bank at 0, 1 bank at 4000, 1 bank at 8000, and 1 bank at C1000. And then you've got is it 48 banks, so 0 to 47 in when you've got the 768, well, the 1 meg next, and when you've got the 2 meg next, you've got what is it, 207, is it? No. Yeah, 211. I think. 64 and 40. Yeah. 211 or 212 that you can pick from. So 0 being the first one. Oh, 212 is, sorry, that's the 8k bank numbers, so it's half of that. So it's 66. Is it? No, it can't be right. Let me get a calculator. Confused myself, right? So we got yeah, so we got 47 and well, sorry, 48 and 64 is 112. Yeah, 112 banks, and yes, it is 16k. We've got 112 16k banks, so that's 0 to bank 111. Yep. Yep. And then in the 1 meg 1 meg machine, we have 1792k free of RAM. Banks double. So yeah, 112 for the 2 meg version, and then 47 banks for the 768, like the 1 meg version of the next. So that's 768k, not 756. Ped, I think you got your number wrong there. So yeah, 0 to 47 you can go with your 16k blocks, and then 0 to 111 for the 2 meg RAM version. Right, has that cleared it up for you a bit, Nigel? There is a manual, Debatable Truths. There is a manual. It's online, and it's also the one that comes with the next. Okay, you understand it better now. Cool. Yeah, basically they're separate. It's like you've got 47 banks to choose from. Well, 0 to 47. So you've got 48 banks to choose from, and you can put any of them in any order into banks 0, 1, 2, and 3, which is your 64K, which is 0, 4000, 8000, and C1000. Right. Store HL as we change it. Here. Store DE as we change it in here. Store BC as we change it in here. And again, store A. I know it's AF, but it's only A that we're as we change. I suppose we're storing the flags as we change the flags also. Store it in. See, then plus the separate, aren't they really? In here. HL times 256. Does anyone not know how this is? HL equals A times 256 in these two lines. You can just ask DJNZ, is that where it checks the flag in register F? No. The DJNZ is, it decrements the B register, and then if it's not 0, well, it does a D, which is the decrements B, and then the J is jump NZ if not 0. So decrements B and jumps if not 0 to wherever you tell it to go to. Yeah, thanks, Ped. Yeah, exactly, Matt. The hardware manual is probably best waiting until it's totally finished before we write a definitive one, because they're in the middle of changing it at the moment. So when it's been changed, it'll be up. Well, the manual is constantly being updated, and will be for the next version of the manual, which goes out with the Kickstarter 2 machines. So Phoebus will be working away on that. You don't know how HL gets multiplied, right? Okay. What's the best thing to do here? Okay. Right. So A equals, say A equals 1 1. No, sorry, 0 0. Because we want to do say we want block 10. Actually, block 11, because block 0 is a number. So A equals 10 there, which is 1, 2 plus 8, So it's 1, 2, 4, and 8. So 2 and 8 is 10, right? So, and what we're doing is we're putting it, so we've got, so HL, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right. So, sorry. So say, oh, hang on, didn't mean to press that one. Right. So, oh, yeah, there we go. Right. So, say this is L. This is the L register, and this is the H register. So if we just set, let's put that back to 0 so I can explain it properly. Right. This is the HL register. The high byte is the H and the low byte is the L. Right, so if we just set L to A, it would be this, and it'd be 10. But because we're setting it in the high byte and setting L to 0, it's then string, actually we know that's 256, so 512, so 512 plus 1024 and 2048, 2048 equals 2560, right? And then basically 10 times, which is what we set A2, times 256 equals 2560. So this is why I, in the first episode, I went on about why binary is so important. It like, say you wanted to, right, say you wanted to get a number. Yeah, actually, I did a number here, can't I? Someone give me a random number between 0 to 255. Come on, first number 0 to 255 gets used in this. 24, right, 24 equals 1, 2, 3, 1, 1, 1, 2, 3. Right, 1, 2, 4, 8, and 16 is 24, right? Now, if we wanted to times 2 equals and that is 16 and 32. 16 plus 32 equals 48 equals 2 times 24. Now if we wanted to divide by 2 equals which is 1, 2, 4 plus 8. 4 plus 8 equals 12 equals 24 divided by 2. So basically, like, say we wanted to do 24 times 24 times 24, right? What you do is so you need to go 1, 1, 1, 1, because you need to times it by this bit, so that's shift up 4 times. So it's 1, 2, 3 plus the 1, 2, 3, 4, and then it would be 1, 2. Actually, if I put another nose in there, so that's what you do. 1, 2, 3, and then 1, 2, 3, 4. Yeah. So find out where 2, 3, 4. Right. So it's gone into 16-bit number, and then we'd add them together. Oh, actually, you can do it in here. So it's 256 plus 128 equals 384. And 256 plus 512 equals 768 plus 384 equals 1. 1, 1, 4. Alright, one more. No, that's wrong. And I'll go from the back, it's easier in it. 12, 8, 14, 15, 10. 1152. Right, so 24 times 24. Now, have I gone too far? It's 576, isn't it? Let's divide by 2. Yeah. Yeah, basically we're shifting the value 8 because we're times it by 256. Actually, it's, hang on. Yeah, B. That. Yeah, it's 1 to 8. Hang on. I'll scrap that. Anyway, it's 1, 1. And then times, yeah, it's 1, 1, 1, 1, 0, 0, 0, and then 3 zeros. Yeah, and then 1, 1, 0, 0, 0, 0, 0, 0. Right. So you basically break it down to what? And keep doing that. 1. So we break this 24 down to the 8 and then the 16. So we want to get our 24, which you can see here, and then there's the 3 bits that we shifted from here to times it by 8, and then our value here, and then the 4 zeros, the 4 bits that we've had to shift. See if it was times 1. If it was times 1, there'd be no shift because you don't shift a number, and it's times 1. You get this bit, and it's 4 zeros, and there's the 4 zeros, right? So let's close this back up again, and then 4, 5, 6, 7, 8. So it's equals 128 plus 64 equals 192, and equals 256 plus 128 equals 384, and now equals 192 plus 384 equals 576. There we go, got there in the end. So basically that's how you do multiplies. What you do is for each bit, like start off with your initial value. Well, it starts off with 0, and then for every the number you're multiplying, like say we've got, we're multiplying by 24, right? And start off at 0, and then so these and you've got 1. So what you do is, because you're multiplying by this, every time you on the first value that you're multiplying, if it's 0, then you don't add it to your total, which is 0. Put our total over here, and then our total over here again is 0. But what we've done, when you're doing a multiply, what you do is for each bit you would rotate. For each bit that you check, you would double the multiplier value. Like so we're multiplying by 24 here, or well, we add 24. Like so it starts off with like HL, like say you're doing mult. Right, so you got your HL value here, and this is your multiplier. And right, so start off with 0. Because it's 0, you don't. Yeah, I'll explain it this way. Because this bit is 0. Add in the last one. Because we're doing 24 by 24. Right, and then 1. Hopefully this will make it clearer. Right, so say we had a multiply function which would basically start off with HL being 0, and then if the bit in the value that you're multiplying by a number, but by the 24, if bit 0 is 0, then we don't add anything. If it was, we would add that to HL. So our multiplier hit, if once you yeah, it would still be 11000, but we're not gonna what we do is after each bit you 11000 11000 So what you do is you keep adding, keep doubling the multiplier, right? So this would be 1, 1, and 1, 2, 3, 4, 5, 6, and then 1, 1, 1, 2, 3, 4, 5, 6, 7. This would add this value to it. So we're adding this, which would be 1 and not and not, and that's not right either. Let's see that. Or is it? Yeah, it is. 5, 1, 2, and 64. Yeah. Right. So, and then if, like, say, yeah, basically that's how you would multiply it. If there was any more bits, then it would just be, you just keep going through for how many bits you want to multiply. But as we're only doing up to 24, I'd rather not continue on this wild tangent. But hopefully that has cleared up the bits. Has anyone got issues with that? I know I was a bit all over the place with it after getting it wrong the first time, but yeah. Have people followed that with the binary? Yeah, you understood the binary. It's good. Yeah, the like I say, that's why we use the binary, and doing the load L with 0 and load H with A basically shoves it up at 8 bits. So basically it does a times 256. So if I get rid of that now, that's not part of the code. And right, add to start of sprites. Get current bank for, and then U1. Store this to bring back the correct bank, correct 8k bank into 2000. Get Y position, and you can see what it's doing here. Now, does anyone know what that's doing? Or know why? Or does anyone not know why? That the and E and then the 3 RLCAs? Do you know what we're doing here? Anyone? No? Right, well, basically what we're doing is we're selecting which third of the screen. The Y position and in with these values, well, we're getting an 8K bank. So normally that would be which third of the screen, and this is what 8K chunk of the screen. Or if you look at it this way, right, this is going to be the high byte of where the screen is. So because the low byte is the X position, because the screen is 256 bytes across, so each pixel down is 256 bytes, so it ends up being the high byte, so the Y pixel ends up being the high byte of what address you're writing to. Right, so this would be 1, and then 2, 4, 8, 16, 32. So 32, 64, and then 1 to 8. Right. So because it's the high byte, this is 256, 512, 1024, 2048, 4096, 8192. So 8K. So that's why we're choosing which 8K bank to select. But because when we've ANDed it with E0, we've got the bits here, but because we want it as a bank number, we want it to be from 0 to 7. So we want them 3 bits to be here. So we rotate it left with carry. Well, it's sort of without carry. Rotate left RLCA, right? That bit goes into carry, but also gets copied. Oh, sorry, that bit rolls into carry, but also gets copied into bit 0. Now, if you do RLA, what happens is you get the C is the carry. So depending on what carry is, which will be 0 from because we're doing an AND, which clears the flag, well, clears the carry. Ignore that routine. No, that. So it's just saying after the AND, if we did RLA, what it would do, it was roll this into the carry bit, and then because the carry was 0 from the AND, that gets put there. So the old carry gets put there, and that goes into the carry, that one. But we want to bring that one in here, in there. So that's why we use the RLCA rather than the RLA. Yes, the add a comment 9 times 2 is load A with 18. The reason I put 9 times 2 and not 18 is to make it easier for you guys to understand that it's bank 9, 16K bank 9, which is the first one of the layer 2 screen, first 16K bank of the layer 2 screen. But because we're using 8K banks, that's why I put times 2. See, if I put 18, you'd have not correlated it to the layer 2 start bank. Right. Add base layer 2 8K bank there. Store it in current bank in case of interrupt changing. Right. Right. Set bank. Because if the interrupt occurs after this load current banks plus one array, if it occurs after that, at the very end of that instruction, and we have an interrupt here, then say the interrupt's got a music drive and it changes that particular bank, then when it comes back, when it sets whatever the current bank was, because it restored the contents of the current bank like we have done here, then when it comes back, it will set it to whatever this value set it to. Because if we did it here, we could have an interrupt after this, and then it would change. It would be whatever the old one was before this. So that's why we do that first. So we set the current bank storage for what current bank is, and then we set the bank. Right. Get Y position. And 31 pixels as that's how many are in 8K. So you've got each 8K bank for layer 2 in the 256 by 192 mode has 31 strips of 256 bytes in an 8K chunk. So that's why we end with 1F, because we got the top half of D here, which is the other 3 bits, and then we set the bank with that and then get the screen position. Yeah, point, add, not point. Add offset of strip square 2.28K bank 1, which is string 2000. 8K bank 0 is the first one, which starts at 0. Just in case you're wondering, bank 1 isn't bank 1 at 0. With banks, it starts at 0. MMU register 0 is what's in at 0. Right. Yeah, the 9. Like I say, it's just for better reading, because you know the 9 is the first 16K bank for the ULA, for layer 2, sorry. And set byte of destination address. Right. Set C to 16 for 16 pixels high blocks. Set B to 16 for 16 pixels wide blocks. Get byte of our sprite block. Put it on screen. Point HL to next pixel in block, or next byte in block. E to next pixel. Right, now, does anyone know why I used ink E instead of ink DE? Yeah, they're combined. A and F is combined into a 16-bit register when you're pushing it to the stack. Then you push 16-bit registers. Yeah, the IX and IY have their own offsets. Working on an 8 by 8 pixel block. No, working on a 16 by 16 pixel block for the background tiles. We can put them as 16 by 16 blocks. 16 by 16 pixel blocks. Just so we can edit them with the sprite editor, basically. You know, they can be 8 by 8 blocks if you wanted to. And yeah, Matt Langley got it. We do not ink DE because we don't want D to change. I'm not going to fit to change in there. So I'll do on the next line. To change as we subtract 16 from E later, and would need 16-bit. Right. So decrease B and jump back to DL to BBLP. Draw layer 2 block B loop. If not done all 16, because we set B to 16 just up here. And then, see, basically this DJ and Z is that, but you can't, it's just to save, it's less, it's only 2 bytes for that instead of a deck and then a JR or a JP, which is even more. Anyway, get screen X pointer and subtract 16, taking it back to the start X position of the block because we've just drawn. So if you wanted to do 8 by 8, if you change them two to 8 by 8 and change this to 8, then you draw 8 by 8 blocks. Then we need to and store back in E. Point to next pixel down. Right, now this could potentially have a bug if we were drawing a block at any pixel position in the Y, because it would, if it was drawing like, because we only got 32 pixels in each 8K block, if you were drawing in the last, if you started your drawing in the last 4 pixel, which is like what, 28 pixels down in the block, well, in the bank, if you drew that at the bottom of a particular screen bank, then when you do ink D, you would start writing into 4000 hex, which is the ULA screen. So what you'd end up having to do is you'd have to do a check on here to see if you've gone into 4000, and if you have, then you'd have to change down to the next bank in the current bank, and then you register 1. So that's why we just draw these on an 16 by 16 boundary, so we don't have to do the check on every line that we do that inside the deck, well, the C loop, inside the C loop. Which will basically bring back the whatever page was in MMU1 before we called this routine. Set x plus 1, which is MMU1. We've got 8 of them, 0 to 7. And then finally set the back. Then store F. Store PC. Basically pops them back up the stack because we pushed them at the beginning of this routine. HL. Right. So, did you follow that okay? Yep. It's great, isn't it? When it's like that, Matt, because it's a lot easier. And it's the same with if you wanted to get the screen address, or what pixel address that you for layer 2, it's basically E is your X position, D is your Y position. You set your bank and the Y position with 31, and just set that to D, and or it with your screen address, which particular, not your screen address, the bank that you putting it into, which 8K bank you're putting it into for the Z80, and then you can just load DE with A, and that's plotting a pixel. Yeah, cool. So do you want me to carry on with the print stuff, or do you want to carry on coding? you want me to continue commenting or code? Do some coding next, or what do you want to do? Did you learn enough about layer 2, or do you still want more? Yeah, Matt, it is pretty much like Y and X coordinates for the screen address, because there's a mode where you can set the all 48k of the screen to be in from 0 to BFFF, and you have your code in bank in the 16k bank at C1000, and then that is your screen X and Y position is the actual byte that you can write. So if you just page the whole of the UL the layer 2 from 0 to BFFF, then you basically your screen position is the XY position, and you just write to it, assuming that Y doesn't go below 192. Well, doesn't go above 191. Check pixel. Yeah. Okay. Where is check pixel? Yeah. That check pixel is for ULA. That's probably why it didn't work for you when you were doing layer 2 stuff. Because it needs to, we should change check pixel L2, and I suppose we should do a plot L2. Have we got a plot L2? Nope. Push D we'll do it load C comma A, because we'll have the actually, yeah, load C comma A. So have the pixel that you want to set in the A register. Or we can set it in C actually, so that push D and then load A comma D and string is E0 RLCA RLCA RLCA. Then we want to add string. No, we don't want to do that. Oh yeah, add A comma 9 times 2, and then actually I forgot something. We want to load A comma brackets current banks plus 1. Include push current banks plus 1 comma A. next reg MMU register 1, A, and let me do load A, D, and string 1F, or 31. Or string 2O, load D, A, load A, C, load bracket D, A. Pop AF, load bracket current banks +1, A, next reg, and you register 1, A, load it's like pop DE and ret. Right. Push DE, load have we got a plot? There is a version of the plot on I must not put it in thingy then. Do you know which file it's in? Did I put it in MISC or something? Nope. Load thanks. Nope. Can't remember where the file was. Screen handler.od. I was in screen handler. Right, let's go to the beginning. Right, so we've got CLS, draw room, draw block, print, PL or print stuff for layer 2. PL2 plot, plot layer 2, check pixel layer 2. Yeah. Right, okay. It was further up, I just must have missed it when I was scrolling through. Right. Push everything, don't I, and pop everything. I don't even do change the beat register. I don't do anything with HL. I don't need to push them actually. I'll get rid of them because we don't need them, because we don't change HL. Same with done it in bank 6 on this one. That's why we add the C1000 there, C0. Right. So y plus 6 and plus 1. Right. So if we look at current banks, which is in the banks, we've got 1, 2, 3. Well, if we go from the beginning, got actually 0, 1, 2, 3, 4, 5, 6, 7. Got so it's string not to string 1 ff, and then string 20. Actually, if I do just the high bytes to string 3f, string 40 to string 5f, string 60 to string 7f. I'm not going to fit the rest of them on, but it goes all the way up to E0 to FF for this one. And that's why what I do is the stored ones are from what was in there originally before the program runs, and we restore them on exit. And the current banks are the ones that are like actually in there at the moment. So we change these values every time. Like say we want to change the ULA, the bank that's in the ULA. Say we want to change that 8K bank there. What we do is we change this value and then set it into MMU register 2. So these are copies of MMU register 0, MMU register 1, MMU register 2, 3, 4, 5, 6, and 7. And it just refers to each of the 8K. So there's 8 lots of 8K banks that we have in. 8 8s are 64. That's all our 64K. So it's just the memory structure offset here. Glad you've got that sorted. Right, so what do you want to do now then? You never followed that. Now you do. Excellent. That's what we want. So now you know why we store the current banks and the stored banks, what they were originally, so that we can restore exactly how the memory was laid out when this program was actually called. And we even store the stack pointer and everything. But that's stored elsewhere. That's in main, I think. Right. So what do you want to do now? Do you want me to carry on with the layer 2 stuff, or is there anything else need me to comment in the layer 2 stuff? Yep. Right, so do you want to done any more comments on stuff, or are you okay? You got right. Okay. Right. What shall we do now then? Do we add a projectile? You okay with comments so far? Cool. Right. So I think we need to add our projectiles. I think that would be good. Yeah, we got our plot L2. So 2, 1, go. Have our game loop. And right, we should do a I was looking for the alt to do alt tab then to change the file. Actually, I wanted to just do edit. Now I need to do new bullets.odn. Right. Let's copy. Oh, copy that line and go to our bullets. Bullets.odn. Right, before we forget, we need to go into main and include bullets.odn. Right, x is equals I can't remember. Banks. Nope. Load. Defines. SEQ. Y one bullets D Q. Divide Q3. Bullet size EQ4. Right, at the moment we don't need to put a direction or anything. Right, so we've got our bullet data, which will be bullet size times num bullets. Equal, how many bullets should we have? I'll put 8 for now. Collectible power up. Yeah, we can have the baddies shooting back as well. That's why I'm doing more than just my bullet. So I'm just doing a maximum of 8. I suppose we can make it 32 because we've got plenty of sprites, haven't we? Yeah, thank you. Thank you. Keep forgetting that. Right, init bullets load HL comma bullet data load B comma bullets actually I can do D comma bullet data +1 and then load BC comma bullets times not bullets, that should be X. X bullets. Now there's a few ways of doing this. Right, I'm just gonna do that for the initialization, and it just sets basically if our Y is off screen, the bullet is dead, and that's how we're gonna have the have it know whether it's alive or dead. Add bullet will be load HL comma need to push DE and push BC, which is D equals Y comma X of the nullet bullet, and BC equals Y direction dy dx of bullet. Bullet data load B comma max bullets. Now there's a couple of ways. No, I go through and check for blanks. See, when you if you have like plenty that you know they won't run out before you know they'll all be dead before it fills up the buffer. If you know that, then you could just have a counter that when you like start off at 0 and then increases every time you after you've initialized one. So it starts off at 0, and what you do is you do load E comma A, load D comma bullet size. I know we could just do add A comma A and then add A comma A because that's ×4, but it's just in case this ever changes, we're going to do it this way. What you do is mul D comma E and then add HL comma D. You do current bullet. Yeah, if you had a buffer big enough with enough bullets in that you know that you wouldn't go through, you wouldn't fire all of the bullets before they all, no, at least one of them is clear. No, one of them has died, or not died, or hit something. And what you would basically do is you could have a current bullet and then just increment that every time, and then you wouldn't have to go searching through the whole of the table to see which one's alive or not. So that would get you to the start of the first free, or the start, well, it'd get you to a free bullet, and then at the end of the add bullet routine you just increase bullet, current bullet variable. But we're going to do the other way, which is where we, in fact, I know there's a lot of people will probably don't like using IX and IY and stuff, but I'm going to use IX because then we can do load, because you were talking about IX, IY before. You can do IX plus bullet Y, and then otherwise we'd have to inc HL, load A with HL, and then dec HL to keep HL points into the bullet data. Compare 192 and then JR NC comma dot found 3. Right, and then what we if we then set load D comma bullet size, we can then add IX comma DE DJNZ dot loop pop BC pop DE ret. In other words, not found a bullet. So if it gets to here, not found 3. Pop BC load bracket IX plus bullet Y DX comma C load bracket IX plus bullet DY comma B pop DE load IX plus bullet X comma E load IX plus bullet Y comma D ret. Ret. Yep, you have to catch up on the rerun retro robins, no worries. Hang on. Num-bullets. We don't need to define num-bullets yet. I suppose we could have bullets for you and bullets for baddies, I suppose. But I was going to give people access to all of them. And then just give you a delay between when you can fire and fire again. Right, so we've got initialize bullets, add bullet, update bullets, load ix, comma bullet data, load p, comma max bullets, loop, ix plus bullet y, compare 192 jr nc, comma skip. Right, add a, comma ix plus bullet dy. Now the reason I'm doing these all 8-bit, in case you're wondering, is because we can only move diagonally, so we don't need fractional values. If you were going to do like bullets that went on an angle to hit a target, then you would need fractional bullets, so we can do that another time. Load bracket ix plus bullet y, comma a, load a, comma x plus bullet x, how many, didn't spot that. He was kicking off again. Don't know if you can see it behind the start to stream. Right, David ix, a, comma ix plus bullet dx, load bracket ix plus bullet dx, bullet x. Right, now we need to do when it's gone over the edge. So as we will only, yeah, probably best not. Right, what we need to do, a ix plus bullet dx, bit 7, a jr nz, dot left, right, add a, comma ix plus bullet x, jump c, comma dot kill bullet. Right, and then jump, skip, dot left, load add a comma bracket ix plus bullet x load bracket bullet x comma a x plus bullet x comma a, and then jump nc comma dot kill bullet, and then actually jump c comma skip dot kill bullet load bracket x plus bullet y comma 255. Add right, add ix comma de. In fact, I will do it here. You're not understanding the differences between X registers and the other pairs. Nigel, in what way you're not understanding the IX registers? Is it the fact that you can add an offset? The basically this you can still do load A with H, or you can do load A comma XH, or load A comma L, or the load A comma XL, and they're the low bytes and high bytes. Or you can do where you've got load bracket HL comma 255 with IX. You've got an offset value on the 255, so we can change that to bullet X or bullet Y, or what bit are you not understanding about the IX register pair, Nigel? Yeah, as Ped said, there's you can yeah, basically the IX and IY can do the plus and offset, but they're slow, or they're slower than the other registers, because it's got to read the extra offset byte and an extra not just the extra offset byte, but another byte to say that it's in a bank of IX instructions or the IY instructions. So yeah, it can take a lot more instructions to do the IXI, a lot more cycles to do the IXIY instructions. But there's pros and cons. You can do things like ix plus bullet y, so it's a lot easier to read than inchl load a with brackets bullet hl, like we've got here the load a with ix plus bullet y up the top. Let's move the cursor to it. Yeah, load a with ix plus bullet y. What we'd have, if it'd have to be inchl load a comma bracket hl dec hl to keep it back to thing in case we had to go to skip. And then it's you having to remember where the HL is, so you'd skip and then you'd jump inc HL 3 times here, and then add a comma brackets HL, and then dec HL load HL with a to get back to bullet y, and then you'd have to inc HL to then do load a with brackets HL, and then bit 7. Well, you'd probably do a dec HL and then bit 7 comma a. You do the dec HL there to get back to bullet x because you're going to use it here. And then so it'd be add a with HL, load HL with a, jump C comma kill bullet, jump skip, and add a comma brackets HL, load brackets HL. But it's a lot more readable to do it with ix and iy than it is to mess around, possibly cause a crash if you get it wrong, or if you end up putting HL to like bullet y instead of the next bullet x position or whatever. So yeah, there's, like I say, there's pros and cons to using HL or using ix and iy registers. Just different horses for different causes. Like I say, it's easier to read if you do ix plus than having to keep track. So that's why I've shown it here. Obviously, with doing the inc HL and dec HL and that, it will a lot of the times be faster, depending on what you're doing, I suppose. But or if you've got a big array of data, then it's definitely quicker. Like if you're doing like a character's information with this x position and it was 16 or 24 bit, and the y position 16 or 24 bit, and then you've got like this animation type is frame inside that animation, and is like what things he's got picked up, and if you've got like a huge array of values for that data, then I would use ix iy every time, just for the simplicity and optimization, well, the speed of reading and writing. If you really needed to optimize that routine, then you can, but I initially write it in plus ix, well, ix plus. So it's more flexible in looking at memory locations, but slower. Sometimes faster depending on the case. So yeah. Right, let me just double check this to make sure it works. Right, bullet data, bullet size. We don't need that bullet size because that's set at on the skip as well. Right, bullet y, compare 192, let's jump skip. Y direction, store it in y, get the x direction. If bit 7 is clear, then go left, otherwise go right and add the value, and then jump carry means you've gone off the right of the screen to kill bullets, otherwise jump skip. In fact, we will change that to test, and this skip will be C. I'll change that back to jump n C, comma kill bullet, and then dot test will be load put x load d comma ix plus bullet y call check pixel L2 and just check that it is check pixel L2. Yep. Stores all the registers. So back to bullets. Check pixel L2 and does it come back with? Yeah, comes back with our value in A. Right. grz comma dot skip, and then if it's not 0 then it will kill the bullet. Right, let's update bullets. Draw bullets. Draw bullets. Right. Load ix comma bullet data. Load b comma max bullets. Dot loop. Load a comma bracket x plus put y compare 192 jrnc comma dot skip dot skip load d comma bullet size add ix comma d djnz dot loop. Right, and then we need to push push bc, pop bc, and then we want to load e comma a, load d comma north, add d comma 32. Load L comma bracket ix plus bullet. Oh, actually, it is load. I add a comma 32. Load L comma a and load e comma bracket I plus bullet x. Delete that line. Right. Then we need to do load c comma. I can't remember what blocks they were. Right. I'll put it at 1 for now. And then load b comma 0 call add sprites. Right, let's just see what the load player 2.odn Right, it's a draw sprite and sprite. We've got H as the other bit, right? Okay. Let's copy that. There. H1 copy. Right. Here's that sprite. Really have more. It's underscores for spaces. Right, so we've got draw bullets, update bullets, init bullets, and add bullet. Right, so if we game 2, call init bullets. Call draw bullets. In fact, what I'll do is I'll put that there and then call update bullets. I should call handle bullets. 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 Num bullets in it bullets. Oh yeah. That's not num bullets. That should be bullet size. Thank you. Well spotted. It's bullet size times max bullets, and it's -1 because we don't want to, because we're already setting the first byte and pointing DE to the +1. So the first LDIR will basically write the second byte. So that's why we do the -1. Yeah, no worries, Nige. I'm glad you've understood the differences between the IX and the normal register pairs. It's like, you know, when you can do like rotating RR and then rotate C or the H register, or you can do IX plus and then X. So it's a lot more versatile. It's just a bit slower. You can do a lot of things with the IX stuff. And same with when you're doing, like say you wanted to check a certain bit, like we could have done bit 7, comma, brackets, IX plus bullet, bullet DY, or bullet DX even. We've got it down here. The other day with DX we could have done bit 7 of IX plus, but although I did need to keep it in the A register because we need to add it to the X position. But if you're just testing it a bit, then you can do that instead of having to move HL to point to that particular byte. And you can also do load a comma bracket ix minus 24 or 25, and that will take the ix as a pointer, go back 25 bytes and get the byte from that address. So you can go forward 127 bytes, or up to 127 bytes, and backwards up to minus 128 bytes. Right, so thanks for the mentioning the num bullets, because yeah, that would have caused an issue because we didn't have num bullets defined, and if we did have num bullets defined, it would have been a variable num bullets instead of so again it still would have, it'd have been an address, so it'd have been BC would have been a massive value, and it basically just wiped the memory. So yeah, it was good call on get me to fix that. Right, so we have oh, we need a ret on there as well, don't we? Yeah, well, Crowley's in the toilet, isn't he, or in the bath? So no one could hear him. That's why. Hey, oopsie croopsie. Right. Now what we need to do is add a bullet. So if we let's just see if we can get it past. I'll get it to assemble. Bullets line 13. Line 13. DS commas -1. Eight-bit value. So whose issue is that? Is that no? I can only DS. Oh, that's a bit poo. Can you only DS an 8-bit value? Definitely line 13, isn't it? Yeah. Oh, line 19. 18, 19. Yeah. Matt, if you're watching, or Ped, you need to allow load brackets HL comma -1, because that is still an 8-bit value. It's a signed 8-bit value. That's a bug in your assembler. Bug in your assembler, Matt. Yeah, it's where we kill a bullet off in it. No, it's not. 52. Duplicate symbol. Oh no. HB. HB. Draw bullets. $96. $996. Dot skip. DB skip. What's the point of it being local if you can't have it? Same value. Same label. HB. HB. $56. Symbol 56. Bully. Bullet. Yeah, local vars aren't local. I blame ped as well. Tusk ped. Who did the local vars? Is it Matt or you, ped? Yep. And that's how it should be in the SJS and Plus. It should just crop the well, should allow -128 actually, not -255. Should allow 128 to 25 -128 to 255. Yeah, poke Matt about it then. Locals are planned as next thing. Excellent. Because that would be cool. Right, 67. Yep, dot kill bullet. There we go. Well, it's still working, which is good. Right, now in our game file, in our player file actually, joy F1. Let's see what defines, say, bit A. So it wasn't fire 1, it was A. JRZ, comma, dot end fire. I've already got the setup. So basically we want a load DC now, and it we got a table to do. Right. ADIR. Right. So 1, 2, right, yeah. Okay. Where was the code? Right. Load A, comment brackets, player dir, load load HL, comma player dir to BC, add HL, comma A, player dir to BC, DB. Now this will be off, which is 0 x and minus y and y. Then it will be upright, which will be 1 in the x, comma minus 1. And then it will be 1, comma 0. And then 1, 1. And then 0, comma 1. Minus 1, comma 1, then minus 1, comma 0, comma minus 1, comma minus 1. And yep, that should be it. Then we do load C, comma brackets HL, inc HL, load B, comma brackets HL, inc HL, call, add bullet. You can just use jump, but I don't know if I'm going to do it any more code here yet. Expression 8-bit 106. It's that old chestnut again. Right, so another one for Matt. yes, Ped, you are responsible for everything, so you broke it, you fix it. And if you didn't break it, you fix it anyway. I think that's how the rules go, isn't it? According to Matt. It's not a bug, just hasn't been written yet. Yeah, very true. Matt. I mean, as I've said all along, Odin is incredibly beta at the moment. And when we got it, it was even more beta. So much so that initially it was the editor was a screen-based editor and not a line-based editor, a command line thing, which was just that. And now that we have the full screen editor, it's so much better, so much nicer, so much faster. I'm so glad that it's changed from the original layout to this. So well done, Matt, for that. I'm just bringing it up because someone was apparently saying stuff on whether it was on Discord about it, but Matt asked me to bring it up in the video. So here's me saying that Odin is now full screen editor. Initially, when we first got it, because it was still the editor hadn't been written, basically. When we first got it, it was just a screen-based, no line-based editor. And that's why they had line numbers and everything, so you could reference it. Whereas now there's no line numbers. It's just well, there is line numbers, but there's no physical line numbers at the beginning of it. So you don't have to like list the program. You can just scroll up and down the pages to find it. And this is far better. I think so anyway. Right. There we go. Will it shoot a bullet? Is the question. B. Why is some of them dying? Right. We're not getting a debounce, so we should debounce the fire button because you can just keep holding your button and fire all 32 bullets at once. I wonder why that is thinking they've died there. Right. Anyway. How do I die? It's space or enter? Space. Enter. Exit game. Right. So. Put MISC. That should have been input actually. Oh yeah, just couldn't copy it, could we? Joy1 deb debounce. 2. Deb. Is the draw sprite. That's sprite stuff, isn't it? That's right. Oh, that's not. Nothing's putting anything on the screen. So I wonder why that was dying. Right. So now we should have it on the debounce. Ah, I know why they're getting left there. Does anyone else know why they're getting left there? Right. Nope, not negative value. Because the sprite's just getting killed. It's not clearing the sprites off the screen, so the sprites are just getting left where they were when anyone is initialized. Like, say you draw two bullets, and one goes first, and then the other one fires second, and then that one gets killed. This one becomes the first one, because when it's drawing them, it draws from 0, from sprite 0, so that one gets drawn, but this one was still here, and this one was still here, so this one gets this number 2 gets left there, but carries on. So that's number 1, sprite 1, which was up here, but died, so that gets drawn up here, and then that one was left, and that's why. So this should now fix that issue. Because we weren't turning the sprites off. We were stopping printing them, and then because the print routine just prints when they're being used, it was leaving spare ones when it wasn't updating as many that was actually on screen at that time. So right, what we need to do is our sprite position as well for when we're drawing our players. The sprite position is wrong because it needs to have the center of the sprite on the dot that we're using for collision. Or I suppose we should be using box collisions rather than dot collisions now. But it'd probably still be best to put the position of the tank, well, the center of the tank as your position. See, because I hit that before I got to it, and then I will hit this before I get to it, and then I won't hit this until after I get to it, and same it down at the bottom. Right, so we got our bullets. Now we need to actually, let's have our bullet routine. Do you want me to comment this or go on to the next thing, because it's close to 5 now, so there's not going to be much time left. What do you reckon? What do you want to do next? What, do you want me to comment the bullet stuff, or do you want me to do the collision or fix the collision? Did you guys follow the bullets? The coding for the bullets? Is there anything you were stuck on or didn't understand? Okay, we'll comment on the bullets, because we should be able to get that done before dinner time, tea time. Right, point HL to bullet data. Point D to bullet data +1. Set BC to size of bullet data -1. Set byte to 255 as our Y position as Y greater than 192. That's Y greater than 192 is dead. There you go. Fill bullet data with 255. Return. Comment to end. Okay. Right. Store. Push R XY position. Push R DX DY position. Point IX to bullet data. It's not a comment, so it doesn't. It's a comment, so it doesn't fix the IX. Right. Set DE to bullet size, and size is the array of the data for the bullets, which is the X, Y, X speed, well, X direction and Y direction. Set B to max bullets. Get bullet y position. Check if it against 192. If greater than or equal to 192, then found a free bullet. Otherwise, add the to ix. Point to next bull. Okay. And loop until we checked all bullets. We didn't find a free bullet, so pop DC and DE, then return. Pop BC dx dy. Oh, it's dy dx actually. That's B, and then this is B equals dy, C equals bx. Right. Set bullets dx. Set bullets dy to B. Pop d equals y equals x. Set bullets x to E. Set bullets y to D. Right. Right. Point ix to bullet data. Set B to max bullets. Get bullets y position. Check against 192. If greater or equal jump relative to B skip. I'll get rid of relative there. Add bullet dy to r to a plus y pos store in bullets y position, or I should say set bullets new y position. Get the bullets x dx check the sign bit. If clear, no, if set, then jump to .lt. Otherwise, add to add bullets x position, set new bullet x position. If C carry set, actually I'll put carry instead of C because you got right off the right edge of screen, then kill bull. Right, check background. Right, add bullets x position, set new bullets x position. Then if carry not set, off left, kill bull. Get set E to bullets x position, set D to bullets y position, and then call check pixel L2 if z z flag is set, then not hit anything, any wall. Not hit any wall and jump to. Then there's no real way to do another line. set bullets y pos to there. I position to 255 off screen. Set D to bullet size, which is the size of array. Add D to ix. Point ix to next bullet. Deck B and to dot hb loop if not 0. Turn. Right, so we've got draw bullets. Points ix bullet data. Right. Set B to max bullets. Get bullets by position. Check against 192 if greater or equal to 192. Jump to .db skip. Store B, I'll push B. That's where using it. As we're using B. Push. Add 32 to y pos. Set L to pos. Set E to bullets. Position. Should have it right. Then D2 0. So as add sprite uses DE as xpos because the it's got 32 values at the left of the screen, which is in the border. So we need a 16-bit value for the X position of the sprite. That's why we use DE. Add 32 to DE. to make 0 be 0 in the ULA area. Area. That's weird. Right, hang on. T-E-S-T. It puts them in backwards. Thought so. Wasn't me. It's the way it puts them in. There's another bug for you, Matt and Ped. If I do test, right? So if I go to the end and T-E-S-T, and come back here and definitely pressed S and then T. I wasn't doing it quick. I wasn't pressing one before the other. It was definitely T-E-S-T. Area. B. Left in ULA area. Nope. Nope. It'll have to be 0. Make 0 be in ULA area. That's even better. There we go. Right, so I can't remember what tile we had for the sprites for the bullets. I'm going to try 3 because I think I did that. I don't know. We shall see. Nope. That was the oh. Right. 2. Nope. Right. 12. Hey, there we go. I knew I had one done. Need to get the bullets moving faster than the tank. Right. Set C to our bullet sprite. Add sprite. Pop PC. Set D to bullet size. Add D to IX. Point to next. Bullet. Do all bullets. Return. no worries, Ped. Yeah, that'll be why then. I understand why it puts it in backwards then as well. Cool. So yeah, that's the whole of bullets commented. Is that okay? That nice and clear for you, everyone? Yeah, Stuart, I couldn't remember what the bullet value was for the sprite. Wasn't sure whether it was before the baddies or after it, before the player or after, and it turns out it was after. So hence it's 12. It'll probably be different on yours, or whoever's watching. It'll probably be different on yours depending on how you did your sprites. That's 12 is the number of the sprite that you did for your bullet sprite. You want to increase dx and dy to go faster? Yes. The way we do that is in player 2. Unfortunately, instead of like -1, we could have done -2, but now we're going to have to do 254, or we could even do better and do 252 4 2 4 4 4 4 2 4 252 252 and 252. This may be too quick, I don't know. That's alright, isn't it? There you go. So, do you know why I did the 252? Because it's basically -4. Um, 255 is -1, -2, -3, -4. Yep, there's no outrunning the bullets now. We could do it at 254, and then that way it's only 2, 2, 2, 4, 2, 4, 4, 4. You can't outrun the bullets, but that's slower. Is that okay? That better? No, That's going around in a circle perfectly. The wrong direction. Yeah, you probably made a wrong value in the table. Right, I'll show you the thingy again. Basically, you got free. If you do it like this, oh, I can't do it like that. It doesn't put it on the next line. So if I do, db 2,254, and then db 2,0, and db 2,2, db 0,2, db 254,2, db 254,0, db 254,254. There you go. Is that better? So you got 1, 2, 3, 4, 5, 6, 7, 8. So you got 0, 254, which is up, right, down, right, down, left, left, left. So this is out, left and right, comma up or down. So up and down. So up is -2 or 254, and down is 2, and right is 2, and left is 254. Is that clear enough? Yep, cool. Yeah, that's what I thought. It's a lot more easier to see as well. You know what direction's going wrong, you just look at your table, and then go down left. That down left. It's right because it's not right because it's a 0 instead of a 2. Down. Actually, what I should do is right. I think we shall call it a day for now. Maybe next week we can do the collision with the background for the characters. Yeah, maybe the collisions with the bullets. giving them some AI, which is going to be interesting to say the least. I'll come up with something. What I might do is next Sunday do head over heels update, and then Sunday after, and alternate between Sundays. No worries. Glad you're enjoying the show so far. Glad you're enjoying the tutorials, and I'm glad you're picking things up as you go along. And that's why I wanted to do, well, one of the main reasons I wanted to do this live, and encourage people joining in with the live shows, because you get like it's intuition, because then you can ask the questions there and then and get everyone at the same position, and hopefully no one gets left behind. Apart from the people that started late and are catching up, but they will hopefully at some point get into the get up to date and join in. Excellent, Nigel. Glad it's, well, that's why I'm doing them, to answer any questions you have with the learning machine code and bits of like what you don't understand in layer 2, and describing the bullets, what we were doing, how we were doing it, the trick with the screen positions for layer 2, the fact that the D is the Y position, and it's also the Y address, used in the Y address, because it's like 256 bytes down to get the next pixel line down. Yeah, all little things like that on addressing the screen and stuff, and it and same with the shifting the bits to get them in the address. And again, that's why I did the binary at the very first lesson, and especially you will need it, especially when you start doing ULA stuff, because let's find a, yeah, put it on the screen, handler, right, copy that, paste it there, and then so ULA address is got your it's 010, which is your 4000, and then you've got yeah, if we do the 16 bits, five bits is your X character, position, and then you've got your Y pixel, that's Y character, it's X32's, yeah, it's the Y character, CHR, and then you've got Y pixel, and then you've got YY third TH. So the Y character is the, like say in the top third. So in the top third, that will be 0, 0, and then whichever Y character you want, like say you want the fourth character down, it would be that, and you want the 2 pixels in, put a space in there, and then 2 pixels in, it would be 0, 1, 0. And then you'd have your 0, 1, 0 here as well. And then that's what character you want. So say you want the 8th character over, and that will be your screen position. And that's the way what you do is you get your X position and your Y position. You have to sort of move the bits around. So the character, these 3 bits and these 3 bits need to swap over, because that should be your so that would be 0 and 1, and then this would be 2, 1, 0 and 2, 1, 0. Actually, so that would be 5, 4, 3, and then 7, 6. That's the bits of the Y position. So normally your Y position would be 7, 6, 5, 4, 3, 2, 1, 0 for your byte for your Y position. So what you'd have to do, you have to split the sections and then swap these 2 sections over. But this goes into the top 3 bits of the low byte. These go into the bottom, well, these stay in the bottom 3 bits of the high byte, and then these 2 high bits move into bits 3 and 4, because that's the low byte and that's the high byte. So that's 6 and 7, but they're in bits 3 and 4. So that's when you're dealing with the ULA. So it gets a bit messy. That's why you need to know about bits, because it becomes a lot clearer when you're calculating screen address, when you know that they're the bits. If you see what I mean. So, like for instance, say you wanted to write plot a pixel at someone give me a coordinate, pixel coordinate, x and y. Ten, 23. 23. X equals 10. Y equals 23. Right, so it would be 10 would be 0, 0, 0, 0, and then 1, 0, 1, 0, and then we'd have 23, it would be 0, 0, 1, 0, 1, 1, 1. Right. So we got X and Y. Oh yeah, and the bits for the, and these are 7, 6, 5, 4, 3. So what you do is, if we copy this again, and then copy this again, so we've got our address would be 010, and then this bit 7 of the Y, which is 0, because here's our Y position, and 6 is 0, and then our Y 0, 1, and 2, which are all ones. Well, 2, 1, 0, they're all ones. So this would be 1, 1, 1, 1, and then this would be Y 3, 4, 5, 5, 4, 3, which is 0, 1, 0. And then X is 7, 6, 5, 4, 3, which is 0, 0, 0, 0, 1. And then that would be the address, which would be 4, 7, and then 4, 1. That would be the screen address. And then the X, and with 7, or the bottom 3 bits of the X, which is 0, 1, 0, you need to set bit 2. So if you do poke, hang on, let me just see what that is in hex. 4741. Sorry, 4741 is poke 18241, comma 4, comma 2. Yeah, because 0, 1, 1, 2, and 4. So you want to set there. Yeah, comma 2. No, set bit 2. Sorry, which is 4. So if you do poke 18241, comma 4. Right, let me just save this, and it's 10, comma 23. I won't be able to plot it, will I? Because it's, the screen is, well, plotting basic is the far left. But yeah, it's poke 18241, comma 4. So if we exit out and we've saved all and quit, poke 18241, comma 4. There you go. 10 poke, what was it? 1821, comma 4, 20 plot 175 minus 23, comma 10. Hang on. What? Oh, it's comma 2. 5, comma 0. That is x and y, so it's 10, comma 23. And 2, it should be. No. The 2. It's the other way. 1 to 8. 60. Yeah. Hang on. 1 to 8. This is 32. There you go. That's good in. Let's let it in. Yeah, it's it is brackets 1 shifted up brackets 7 minus and then R2. Because the left pixel is 1 to 8, or left pixel 0 is 1 to 8, and that's why it's 1 shifted up 7 minus and then the x and 7. But yeah, that's how you calculate the ULA position for a pixel or screen character, or basically if you remember these, this bit here, you can't see what I'm pointing to with the cursor, so yeah, you'll have to remember these bits. That's how you address the screen for the ULA. Or you can just use pixel add. Okay, yeah, that would help. That would be an issue too. Right, let's save that and quit. And yeah, we shall leave that there, and I'll let you get back to your weekends. Have a good one, and thanks for watching, and thanks for joining in. Yes, Ped. Pixelad is specifically for doing all that shifting around of the bits, and the set A sets A with the actual byte value to or poke into the address, write into the address, just to make it easier for plotting pixels and stuff. Having to set specific bits. Now it's the x, it 1 shifted up by 7 minus x and 7. Have a great weekend. See you all next week. The update of Head Over Heels. hopefully in 2 weeks. Tutorials 2 weeks, and then the updates will be every other week. Well, the alternate week. Catch you later. Right.